Welcome to Lab 4. This lab is where you get to exercise your creativity. You'll modify your present robot to become a maze-running robot, and you will have some flexibility in how it is built.
You will write some software for your robot in this lab, but we're saving the big programming that will get you through the maze for the next 2 labs.
The ultimate objective here is to build a robot that can solve a line maze quickly. That is, the robot will follow a center line, but is always watching for cross lines and walls so that it can take special actions when those are detected. Don't worry about the programming just yet.
First, build the hardware of the robot. Remove the 2 ultrasonic sensors that you added for the chicken bot and put them aside. This returns you to the basic education bot design.
Now your maze bot already has one sensor from the education bot, but you need to add a couple more. Next to your existing light sensor, add a second light sensor, also facing down, even with your first light sensor, and a couple inches to the right of it. This will be used to detect a cross line on the right. It should be low and close to, but not touching, the board.
Now add an ultrasonic sensor facing forward and low enough to see a wall in front of it. It doesn't matter if it's oriented vertically or horizontally, just make sure to keep its eyes free of any obstructing wires or sensors.
Finally, add a second ultrasonic sensor at the front of the robot, facing to the left and low enough to see a wall on its left.
The way in which you attach these sensors is up to you, and there are multiple acceptable placements. Just remember to keep your wires away from the wheels and follow the general placement guidelines.
Now that you have built your maze bot, you need to write software for it. You aren't going to try to solve the maze just yet. Instead, you're going to write some simple program pieces.
First, we'll start with Uturns. Open up the LEGO Mindstorm software and select New Project. The first piece of our program will enable the robot to travel back and forth in a straight line. To do this, your robot needs a couple of blocks of code. Start the program with a forever loop block. Inside of it, put an infinite move block followed by a wait block. Set this wait block to time and have it wait for 2 seconds. Then put another move block in and have your robot do a spin U-turn to the left. The number of rotations the motor will need to turn will depend on how you built your maze bot. Fractional rotations are allowed and even encouraged. Remember, your maze bot must U-turn in place. This is what spinning means, not pivoting, so that it can easily find the center line again when it has completed the turn. Don't forget to save your program, and make sure to use a sensible file name like U_turns.
Download your program and test it. Your robot should now go back and forth along a straight line. If it doesn't, there are a couple possible sources of error. Make sure nothing is in the way of the wheels that might keep them from turning correctly. If the U-turn is not precisely 180 degrees, you should adjust the number of wheel rotations used for your U-turn's move block.
As you can see in this video, our robot's U-turn was a little bit imprecise, so we went back and edited the code.
Next, we'll work with right turns. Create a new program where we will program the commands to make the mazebot make right turns and form a square. Start with a loop block with a count of 4, and inside it, put the blocks to make your robot go forward for 2 seconds. Then do a right turn. Just like the right turns you did in the loop exercise earlier, we want these turns to be spin turns, not pivot turns. Remember to name your program.
Download it to your EV3 and test the program. The robot should carve out a square and then stop. If it doesn't, change the number of wheel rotations until it performs right turns, and make sure to save. We'll insert a video of our robot performing the right turns.
You now know the number of rotations necessary for your mazebot to do a U-turn and a right turn. You can use this info in Lab 6 when you complete the program for solving the maze.